Hi, everyone. Welcome to class today. Ballet's taking a walk. It's great to see you all. Anybody have anything they want to share or any questions? All right, great. If not, we will jump right into our class today. All right, hopefully you can see the beautiful mineral picture there. Can everybody see that? Good, wonderful, wonderful. All right, so we are going to talk about minerals today. We started the unit about minerals last week. It was due on Friday. So if you're keeping up with the due dates, which I do recommend, then you know what I'm talking about. So if you have one of these mineral kits, if you got that, get it out now. If you don't, if you got rocks, get them out now. You can just use rocks from your driveway. That works just as well, or from that you find out in the yard. Maybe not just as well, but you can get the idea of what it is that we're doing here with these. So we're going to test some minerals today. They also sell, the same company I told you in the thing sells a rock kit. So you can get the rock kit too. And you test your minerals and rocks exactly the same way, which is why it works for you to be able to get ones from outside and the driveway. Just keep in mind that, you know, rocks are made up of minerals, which we'll talk about, so that you can use either rocks or minerals for what we're going to be doing today. All right, so before we get started, I have a couple reminders for you guys. First of all, keep in mind and remember that AIM Academy is set for Eastern time. So I don't have any way to set it for different time zones, even though you guys live in, some of you, different time zones than the Eastern one. So if you, for example, if you're on the West Coast, that means your due date is actually going to be, your due time, if you will, is actually going to be 9 p.m. instead of midnight. And there just isn't any way that I can change that. I do, though, post your assignments at least a week, often 2 weeks before the due date. So I think that gives you plenty of extra time. So those 3 hours shouldn't be a real major issue. Just keep that in mind. And remember that I don't ever take off points for assignments that are submitted after the due date or the due time. The only thing that's involved here is that 1/4 of a point extra credit that you get for each assignment. So I'm going to be sending out progress reports at the end of this week. On Friday or Saturday, I'll be sending out the progress reports. So the only thing that I can use to tell what your progress is how well you're doing as of today. So even though I don't take off points for anything that's past due, if you're several assignments behind schedule, it may be that your progress report will be a little bit low. So just a heads up that that will be coming later on this week, over the weekend. All right, another question, reminder, that plagiarism check. So if you've turned in anything that required you to write out answers, you got a report from plagiarism check. Please just ignore those reports. We're having some problems with plagiarismcheck.org, and it's giving some students really high plagiarism numbers when in fact they weren't copied at all. So we're trying to figure it out. I think I've removed it from most of the assignments, so you shouldn't be getting it anymore until we've got everything figured out. And it could be just a setting that I have to change on it so that it doesn't doesn't give high numbers. Third and final reminder, please number your exam answers. So let's say, for example, I give you an exam and there are 10 questions on that exam. Make sure your answers are numbered 1 through 10. Don't say number 1 is the question and then number 2 is the answer and then number 3 is a question and number 4 is an answer, or just skip answering, putting numbers in altogether. It's just too hard to grade when they're not numbered. So please make sure you use the numbers for your answers that I have given for the questions. Does that make sense to everybody? All right, great, wonderful. So I do have a couple jokes for you. So here's our first one. Name the 3 types of rock. This girl is taking a science test, and that's the question. Here's her answer. Classic, punk, and hard. Classic rock, punk rock, and hard rock. Yeah. All right. Here's another one. Where do geologists sleep? On bedrocks. How can you tell if a geologist is mad at you? He gives you the cold shoulder. And what is a geologist's favorite restaurant? The Hard Rock Cafe. I like that. All right. And I think I have one more here too. What do you, oh, no. That's sorry. I jumped ahead too fast. Hard Rock Cafe. Okay. So let's talk about minerals. So like I said, you started reading about minerals last week. In order to be considered a mineral, something has to meet these 5 characteristics. It has to be naturally occurring. It has to be inorganic. It has to be solid. It has to have a crystal structure and a definite chemical composition. All right. Now, a lot of times people confuse rocks and minerals. So let's right off the bat talk about the difference. What is a rock? Well, a rock is something that's made out of minerals. Now, there might, oh, Isaac. Can't hear you, Isaac. Your microphone's not working. Not here, yeah. So you can think of a rock. Think of a rock like a big cookie. And a mineral is the ingredients that are in that cookie, right? So a rock has ingredients that are minerals, just like a cookie has ingredients. Now, just like a cookie is made out of things like sugar and flour and maybe chocolate chips, if you're lucky, a rock is made out of different minerals as well. So a rock is some kind of combination of either one or more minerals that have gotten stuck together. So you can think of minerals as the building blocks and rocks as what you get when you put those building blocks together. Now, we are going to learn about rocks next week, but since rocks are made out of minerals, we have to know what minerals are before we can start studying rocks. So what do all minerals have in common? These 5 characteristics. Let's talk about them. Natural. That means they have to have been made on Earth with no help from humans. They have to be made naturally from natural processes. So minerals are not things that are made in a laboratory. So there are things that are made in a laboratory, but we wouldn't call them a mineral because they're not naturally occurring. Isaac, you gonna try again?
Can you hear me now?
Yes.
Okay. Must have just been not plugged in.
Yep. Oh, is that it? Okay. All right.
Just making sure.
Yeah. So a mineral is also inorganic. That means it was never alive. So coal was formed in Earth's crust. It came from plants, though, so it's not a mineral. It was formed on Earth, but it came from something that was alive. So it is not considered a mineral. It is not organic, not inorganic. It has to be solid with that definite volume and shape. So things that are liquid are not minerals. It has to have that crystal structure and it has to have a unique chemical composition. So some minerals are made up of more than one element. So they would be called compounds, but it always has that unique chemical composition. So for example, pyrite, which is fool's gold right here, it always has some sulfur in it. This is pyrite. This is fool's gold. It's a mineral. It always has some sulfur in it, right? All right, so when we talk about the structure of minerals, we said that they have to have that crystal structure or crystalline shape. What that means is those particles, those atoms that are in there line up in a pattern that repeats. So it looks like this. It looks very organized and very rigid, and it forms that crystal structure. Now, minerals have a crystal structure because their atoms are arranged in this orderly repeating pattern. All right, now let's talk about how they form. So basically, they form when magma cools down, and there's 2 ways that that can happen. Either magma cools quickly or magma cools slowly. If it cools slowly, you're going to get big crystals. If it cools fast, you're going to get small crystals. Now, the evaporation of water also has minerals dissolved in it. And that when the water leaves behind those minerals, that gives us, just leaves the mineral behind. So those are the two ways, either cooling magma, fast or slow, or evaporating water. Those are the two ways that minerals can form. So we want to identify minerals. We've got this lovely rock, looks like a rock. It's actually a mineral, but it looks like a rock. We want to know what this is. How can I tell what it is? Well, there's 5 different things that we can look at. We can look at the color or the appearance of it. We can look at the luster, the streak, the hardness, or the cleavage. We can also look at an acid reaction, but we'll talk about that in just a second. All right, so now's when we're going to use our rocks. So I gave you guys this chart. I sent it to you. If you printed it out, you can use it. You can write it down on paper. You can just watch, whatever you want to do, however you want to complete this. This is not an assignment. You don't have to submit it to me. Okay. Now let's take a look at what each of these things mean. What do we mean when we say color? What do we mean when we say luster and hardness and streak color? And why are we not going to test for cleavage or acid reaction? Why is there an X there? Anybody have any guesses why we're not going to test for cleavage or acid reaction? They're actually dangerous. So we're not going to test those at home because they're a little bit dangerous. Okay. Let's start by looking at the color on this chart. So pick up one of your rocks or your mineral. Oh, go ahead, Isaac.
It's not about this, but what is a geode both a rock and the mineral?
Oh, that's a really good question, Isaac. You know what? Let's see if we can find out. I don't know the answer to that.
Because I have some geodes, just want to know if they
Yeah.
is this actually a rock or a mineral both? Because it has crystal
Yeah, it has
in
like
It's also rock.
Okay, so I asked ChatGPT, and here's what it says. A geode is considered a rock. It is a type of rock that starts as a hollow, round rock. Over time, mineral-rich solutions seep into the cavity of the geode. Inside the hollow space, those minerals crystallize and form beautiful structures, often made up of minerals like quartz, calcite, or amethyst. The outer part of the geode is composed of the rock itself. The inner crystals are minerals. So yeah, it would be both. The geode itself, so I have one here on my shelf. I'll pull it up and show you. This is a geode right here.
Amethyst geode?
Yeah, that's amethyst. So you can see the inside is made of crystal. But if you look at the outside, that's definitely rock. So it's got crystal parts to it. Remember, rocks are made of minerals. Minerals are the building blocks of rocks. So it would have the mineral, this complete mineral on the inside, a pure mineral, but on the outside, there would be rock. That would be some combination of minerals, and there would be other things in there as well. Yeah, great question. Yep. All right, so pick up any one of your rocks or your minerals. We'll consider that, whichever one you pick up first, we'll consider that looking at your chart here. That'll be rock number 1. So look at your chart where it says rock number 1. All right, so what color is it? When you look at it, what color is it? I just picked one up here. It's very dark gray. Not quite black, but very dark gray. So in my chart, under color, right here, I'm going to write down dark gray. Dark gray. All right. Now your rock might have more than one color in it. If it does, write down all the colors that you can see. Your rock might have some rust in it. Maybe it's got like red streak in it. That rust would mean that there's some of the mineral that we call iron inside that rock. So when iron comes into contact with oxygen in the air, it forms rust. So you might have a little bit of that red streak of rust in that rock. I'm gonna look and see if any of mine. So if I look at my rock kit right here, I do have one that has some rust in it. I don't know if you guys can see that. Right there, there's little streaks. Kind of hard to tell when you get real close. It gets a little blurry when you get close up. But there's little streaks of rust in that one that has iron in it. All right, now the problem with color can be a little bit misleading because many minerals are going to have a similar appearance. They might have a similar color to one another, but they're going to have different properties. So just looking at your rock, looking at the color and the way it appears are not enough for you to definitively say this is this kind of mineral. All right, the next thing on our chart, we're still looking at rock number 1. So still have your same rock in your hand. So the next thing that we're going to look at across the top there is luster. So luster, let's look at that is the way it reflects light from its surface. So some of them are going to have a bit kind of a shiny look to them. They're going to reflect light back at you and look really shiny. And others are going to be kind of dull. Here are the words that we would use to define our luster. If it's shiny, like metal, we would say that it's metallic. If it's dull and not shiny at all, we would say that it is non-metallic. It might be pearly or silky or glassy, but it's not going to be shiny like a metal. We can also use other terms like waxy or dull or silky. Those are terms that we can use. So look at your rock and write down whether your rock is shiny or dull, or waxy or pearly or glassy or silky, whatever word you think defines your rock. So mine is very dull.
Can you use a polished rock? Is it possible to determine what a polished rock is?
So a polished rock, like one that you would have gotten from a science store or something.
Is it possible to determine?
It is possible to determine. It'll be a little more difficult when we get to talking about the hardness or the streak color. You're probably not going to get a streak color from a polished one. But yeah, you can look at your polished rock. You can tell the color. It's probably all the polished rocks are going to have a shiny luster because they polish them until they're shiny. So for that one, you might, oops, dropped my rock. You might not be able to tell.
I have a massive collection of random rocks.
Yeah.
A massive.
Yeah. Okay, so here we have, my rock is definitely dull. So that's what I'm going to write in the luster column. Now, the third thing that we're going to look at is called hardness. We can test the hardness of our rock using what's called a scratch test, or how easily a mineral scratches something. So we know how hard certain things are. Like think about your fingernail. You know how hard your fingernail is, or a penny, or a glass. Well, we know certain things have a certain hardness, so we give them a number. And the number is on what we call a Mohs hardness scale. Now, fingernails are given a number 2. So if a rock is softer than a fingernail, meaning you can scratch it with your fingernail and you can like dig into it with your fingernail, then that's going to be lower than a number 2. It's going to be softer. So mine actually is. If you guys can see that on the end of my finger, there's some rock that went under my fingernail just from some real light scratching. So I'm really lightly, Isaac, I need you to mute your microphone. Thank you.
Oh, sorry.
That's okay. So when you scratch it with your fingernail, is a little bit left behind under your fingernail. If it is, it's going to be a 1, right? So test your rock and see if it can be scratched with your fingernail. This Mohs hardness scale rates them on a scale of 1, which is the softest kind of rock, to 10, which is the hardest kind of rock. So we can test it by scratching it with different things. So we can scratch it with a human fingernail. If it leaves something behind, it's going to be a 1. We can scratch it with a nail. Your kit probably came with a nail. Drake.
How hard is a nail?
So what number is a nail on the hardness scale? Let me see here if I have that information. I do not have that information. Let me look in and ask.
Like a scrap piece.
Okay, usually a nail is a 4 or a 5 on the Mohs hardness scale. A penny is going to be about a 3. I know that one. Penny's going to be about a 3. Something that's glass or like a knife, a steel blade on a knife, that's going to be somewhere 5 or 6 in that range. So you can take your, if your fingernail didn't scratch your rock, Then take your nail and see if that does. And if it does scratch it, then you know it's going to be somewhere lower than about a 4 or 5, but not a 2. So I would give it a 3. Drake.
Do you know some kind of material that's a 10?
Yes, we'll talk about that in just a second. Yeah, it's a good question. Hold that question because we will talk about it. Okay, so scratch your rock. If it scratches with a fingernail, you would write a number 1 on the hardness scale. If it scratches with not your fingernail, but with the nail, then you're going to give it, say, a 3. And we don't really, if you've got a penny, you can use that, but I didn't tell you to bring a penny, did I? I don't think I told you to bring a penny. So you don't have to test that. If it scratches with a penny, but not a fingernail, that it's going to be about a 2, 2.5, something like that. Okay. If it doesn't scratch with either of them, it's going to be above a 5 or above a 6. So you can just write more than 6 in your little column right there. Oh my goodness, I'm dropping everything. Hang on to stuff. Okay. All right, here we go. So let's see here. There we go. So 1 or 2. Number 1 or 2 can be scratched with a fingernail. Take a look on that Mohs hardness scale there at the kind of rock that is a number 1. That's a talc. Anybody heard of talc before? Have you heard of talcum powder? So a lot of times talcum powder, talc is put into baby powder. It's not really so much anymore. It used to be a lot. But talc is found in that talcum powder. So basically, when you put talcum powder on your body, you're coating yourself with rock dust. So you have to be very careful not to breathe in talcum powder. That dust can be very harmful to your lungs. Now that you know that it's just rock dust, you can see why. So something with talc can be scratched with your fingernail. Something that's a 3, like calcite in the picture, that can be scratched with a penny. Number 4, something like fluorite, can be scratched with a knife. We're not going to test that. That's not safe to be using knives here. Now, number 6 can put a scratch on a glass jar. So we're not going to test that either. Orthoclase is a mineral that can scratch glass. But I don't think any of your parents would appreciate it if you started scratching your drinking glasses. So we're not going to do that. All right, now we come to number 10. What's a number 10? Diamond. Diamond is the hardest of all the minerals. It can scratch everything. It can scratch all the rocks. So if you've got everything that, everything that you use to try to scratch it with, you're not going to put a scratch in your diamond. That's one of the reasons that diamonds are so valuable, is that they're so hard and they last a very long time. Now, diamonds are so hard that sometimes they're used on saw blades around the outside, so that because they can do such a good job of cutting through all different kinds of things. These are wood. They cut wood, these saw blades. 3 times longer life because of the diamonds that are on the outside. Now, we're also not going to test a diamond. Probably none of you have a diamond in your kit. Don't go getting your parents' diamonds and scratching them. All right, that's it for hardness. All right, now let's look at streak. So if you got a mineral kit, you have this little plate. It looks like this. It's called a streak plate. If you don't have one of those, you can use a small ceramic tile that you might have gotten from a hardware store. If you don't have it, that's fine. You can just observe what we're doing here. Everybody who's doing it can hold theirs up. Now, if you got the small ceramic tile, one side of it's shiny and the other side of it is unglazed and not shiny, you want to use the unglazed side. If you have one of these streak plates, both sides are okay to use. Now, the streak plate itself is harder than most of your rocks. So when you rub your rock on this streak plate, a kind of a fine powder is going to be rubbed off the rock. And scientists can tell a lot about a rock by the color that it leaves on the streak plate. The streak is what we call the color of the powdered form of the mineral. So basically, when you rub it on the streak plate, you're turning it into powder. We can find a mineral streak by rubbing it on that white ceramic plate. So like, look at this right here. This is the color of the rock, but look at the color of the streak that it leaves behind. Here, these all you can see right here. This is the color of the rock. This is the color of the streak. So once again, take your rock and scratch your rock on the streak plate. And if you have a little magnifying glass, you might be able to look at it with the little magnifying glass after you've done it and really see what the color is. Then write down the color of your streak. If there isn't any streak, when you scratch it on the streak plate, just write no streak on your chart, because if your rock is harder than your streak plate, you're not going to get any color. All right, Meredith.
Is it fine if my ceramic tile is like a brownish color?
Well, let me see the back of it.
It's like this. It's kind of.
It should still leave. You're just turning your rock into powder, so that should work. That should
Okay.
work fine. Yeah. If your rock is exactly the same color or real close to the back of your ceramic tile, it might not be exactly. It might not show up quite as well, but otherwise it should work. Now, rocks that are or minerals that are non-metallic are usually going to give a light colored streak. So if they don't have any metal in them, they're going to give a light colored streak, where if they do have metal in them, they're going to give a dark colored streak. So take your mineral or your rock and your streak plate and just draw like try and rub it a little bit. Okay, this one, mine's giving, actually, it's completely black. Where my rock is dark gray, my streak is black. So if I look at it with my little magnifying glass, I can really see. So I'm going to write under streak color, I'm going to write black. All right. The color of the streak might be different than the mineral itself. And this is important. The minerals have to be softer than the streak plate. If they're not, you're not going to get any color on the streak plate at all. All right. I saw somebody's hand up, but I don't know whose it was. Are we good? Okay. So far with our rock number 1, we have our color, our luster, our hardness, and our streak color. Now, streak can be used to help identify quartz. Quartz is a kind of mineral that comes in a lot of different colors. But interestingly enough, even though pure quartz is clear and amethyst is purple and smoky quartz is black and aventurine is green, always the streak that's left behind from quartz is going to be white. So if I had a smoky quartz, even though it's black, see here, it's going to leave behind a white line on there. So quartz always leaves that white streak. All right, we're going to look at what we mean by this cleavage and acid reaction, but we're not going to test them. So because in order to test them, we have to break the rock, and it's a little bit dangerous to do that. So cleavage and fracture are the 2 words that we're going to look at. They talk about the way a mineral breaks, and there's a difference between the 2. Cleavage is when a mineral breaks along smooth, flat surfaces, and every fragment has the same general shape. Now, you can kind of see that too. If you brought a paper towel or a Kleenex to class, you may be able to see that. So I'm going to tear this Kleenex 2 ways. I'm going to tear it long ways, like the way that it's folded when it comes out of the box. I'm going to tear it that way. And you can see it pretty much tears straight down. You know, I've got a little bit of a line there. If I try tearing it the other way, it's really jagged. It doesn't tear straight down. It's shredding that. That's because it has what we call a cleavage line. It tears easily along the cleavage line, but it doesn't tear easily if I'm not tearing it along the cleavage line. Now, the same thing is true of some minerals. Some minerals, like the ones in the picture here, have a cleavage line, and it'll have cleavage lines that you can see. So a geologist will test the mineral to see if it has a cleavage line. And if they do, then they'll break 1 or more of the flat edges that are on here, and they'll be able to see how it ends. The mineral will either be irregular and jagged, or it'll be smooth. So we're not going to test ours, because in order to test for cleavage, we would have to break our rocks, and flying rock pieces can be dangerous. So we're not going to do that. Isaac.
I think I just realized, I think I just found that one of my rocks actually is a fossil.
Really? That's pretty
So
cool.
I don't know if you can see it well, but there's actually like, I feel like it's like a beetle or something legs in this rock.
Let me make you bigger for everyone to see. Hold on. Oh, I don't think I can do it when I'm sharing the screen. Oh yeah, look at that. Yeah, there very well may be. We'll talk about fossils a little bit later in the year.
I think it's actually, it's like it's rock right here,
Yep,
but it's fossil on the other
on the
side.
other side. Very cool. Very cool. All right, so when it breaks along a very smooth, leaving a very smooth line behind, we call that cleavage. If it breaks in a way that leaves behind rough or jagged edges, we call that fracture. Fracture. All right, and then finally, you can see the acid reaction there. We're not going to do that one either. That's where you drop some real strong acid, hydrochloric acid, on the rock and see what happens. Because some rocks will be affected by hydrochloric acid and other rocks will not. All right, so let's go back and do the same thing with one more rock, but pick a rock that looks very different. Like this time I picked a very dark gray rock for my test. So pick a rock that doesn't look at all like that. For this next one, I'm going to pick a rock that is there's kind of a creamy color. I got a mineral here that's creamy color. My mineral is microline feldspar. Once again, if you pick some up from outside, you can do this. Just pick a rock that looks different from the one that you did the first time. So back to the beginning. The first thing we're going to do is look at the color. So we're going to write down what the color is. Now, my rock has several colors in it. It's mostly like an off-white with some gray and some brown. So I'm going to write that all down. Off-white with gray and brown. Streaks. So basically, you just want to describe your rock. I'm going to look at the luster. Once again, I have one that it's not really shiny. It's a little more shiny than the other one was. So I'm going to say that this one is kind of silky in the way it's colored or the way it reflects light, because it's not as dull. That first one that I lifted up, boy, it was dull. There was no shine to that at all. This one has just a little bit. So I'm going to say that it's just a little bit. So I'm going to say silky under luster. All right. Now the next thing we check is hardness. Once again, take your fingernail, start with your fingernail and scratch it. Okay, that's doing nothing. That's going to file my nail down so there's absolutely nothing under my fingernail when I scratch that one. So I know that it's not a 1 or, it's not lower than a 2. So now I'm going to take the nail and I'm going to try to scratch that, because remember, nail is a 4 or a 5. So can I scratch it with the nail? Yeah, I can't scratch this with a nail either. I can't scratch it with a nail. Nope. So I know it's not under a 5. Now, the next thing that I could do would be to test it with a knife blade. I'm not going to do that. I'm just going to know mine's higher than a 5. So in my hardness, I'm going to put more than 5. My streak color is next. So I pick up my streak plate and I draw. I try to draw along it. Oh, it's definitely leaving a white streak. Not this one here. Oh, you guys can see that. It's leaving a white streak behind. Definite white. So I'm going to write white under streak color. I'm not going to test cleavage. I'm not going to test acid reaction. All right. Now, if you have a kit, your kit came with an identification paper. So like I just look at the one that I tested is number 2. That is feldspar microline. So the color is going to be white, green, or red. Mine is white with that little specks of the gray and the brown in it. My luster is going to be vitreous. What do you think vitreous means? Anybody have any idea? I'm going to get a definition for you. So let's see here. So it is going to reflect light brightly, but not as intensely as something metallic. It's going to have a smooth look, often translucent. That's a good way to describe number 2, the rock that I have. So you guys may have exactly the same one. Drake.
How hard is bone?
How hard is bone? We don't use the Mohs test to determine bone. Let me see if there's even an answer to that. There is. Bone has a hardness of about 3 or 4. It's relatively soft compared to most minerals, and it can be scratched by materials that have a hardness higher than 4, like quartz or a steel nail. So if you had a bone, you could scratch it with your nail and it would leave behind a scratch. Yeah, that's a good question. Bones, here's the thing about bones. The bone material itself is not all that hard, but the way a bone is put together, the way the lines of stress are on the bone make them very, very strong. Yeah, that's why we don't break our bones when we jump. Ballet.
So I was trying to test one, but it's like breaking off. So it's not like it's like leaving something, but it's just breaking apart into little like flakes.
So that's going to be a pretty soft rock. That's probably going to be a 1. Do you have the rock kit or the mineral kit? What number is it?
12.
All right, so 12 is a, 12 is called selenite. Oh, wait, here. 12 is called biotite mica, and it has a 2.5 to 3. And it does break off into thin sheets. If it's the same as I have, you can look on yours and see what kind it is. All right, if you want to test a third one, you can feel free to do that while we're talking, but I'm going to move on. So if you guys want to test them, I recommend testing all of your rocks. And if you have, so what you've just been doing, this is what geologists do. A geologist is what we call a scientist who studies rocks. So geologists will go through these exact tests in order to determine what something is. So they know, for instance, they know what rocks have a hardness of 4 and a vitreous luster and are green in color. So if they find a rock and they test it and it has a certain reaction to acid and a certain cleavage and a certain streak color, then they will know what that is when they compare it to their table of known minerals. So this is exactly the process that they go through. All right. So there are other properties of rocks that we can use to identify of minerals. I keep saying rocks. They're the same. Rocks and minerals that we can use to identify them. One is fluorescence. So there are some that glow under ultraviolet light. Calcite and fluorite are examples of minerals that glow under ultraviolet light. So you guys, if you got the mineral kit, you probably have the calcite. On mine, it's number 6. So it looks like this. It is a bright white. Unfortunately, I can't show you the ultraviolet underneath there because I don't think it will work. You know what? Hold on just a second. I'm going to try. I'm going to try to turn my light off and see if I can get. I don't know if it's dark enough in here, but here's my rock. Let's see what it does under. There we go. Oh, look at that. You can really see it glowing. This is the ultraviolet light shining on it. So when if you can see it, it looks real pink on the screen, but it's very purple in my room here. So that's glowing under ultraviolet. Let me hold up a different one that doesn't glow under ultraviolet and show you the difference. Now that one's going to glow too. See how that doesn't glow the same way? It's got color on it, but it's not glowing the same way. Turn my light back on. Yeah, so this is just a black light that, you can use for different things. I keep it for science experiments. So that's one way that you can test. Some minerals will glow under fluorescence. That chemical reaction, when a drop of weak acid is put on calcite, it'll fizz up a little bit. So weak acid might be something like vinegar or lemon juice. So if you have calcite, you can try putting a little drop of vinegar or a little drop of lemon juice on yours and see if it fizzes a little bit. We call that fizzing effervescence. Another, let me see here. This one, number 15 on mine, is going to have what's called optical properties. So see how that's clear? You can see through it. If I put that down on some text, it actually makes that image double. I can see two of them. All right. Another thing is some minerals are radioactive because they might have radium or uranium in them. So that could be. Some of them are magnetic. So magnetite and pyrrhotite. I don't think I have either of those. Look in your kit and see if you have magnetite. Number 8 in mine is magnetite. So let's see if we can see. I have a magnet right here. I'm going to see if it sticks. It does. See, there's my magnet sticking to the, there's the magnet. When I put it on there, it sticks right to that. Yeah, there you go, Meredith. Cool. All right, so that way I know that it's going to be magnetite or pyrrhotite or something else that has magnetic properties to it. Now, others have a salty taste. Now, you want to be really careful to not taste things in, unless you know for sure that they're safe. Now, in this case, let's see if we have, I don't have halotite in my kit. So I don't recommend tasting them. First of all, they're going to taste bad. But second, don't taste something unless you know that it's safe. So those are some special properties that minerals have that make them different from other minerals. They help geologists to be able to identify them. All right, anybody have any questions about any of that? Like I said, you can continue testing yours if you want to, both now and then after class. Maisie?
Do we have to submit the rock thing
Nope.
for class?
Nope. No, you don't have to turn anything in. It just was for your fun, for your information to do that today. So it is fun to test all your rocks though, and see, you can test all of yours and then match them up here and see if you got the same thing they did. If you got the same thing that the key gives you. I think that's good to do too. All right, so we talked about minerals and how minerals are the building blocks of rocks. But what are the building blocks of minerals? What are minerals made out of? Drake? Couldn't hear you, Drake.
Atoms.
They are made of atoms, absolutely. They're made of what we call elements. So atoms and elements, they're kind of the same, but a little bit different, right? So an atom is one. An element is a bunch of the one, or even one of the one. So let's talk about the difference between an element and an atom. So an element or an atom here is the basic unit. It's basically the smallest we can go and be still having the same chemical properties as something else. An atom has in it a proton and a neutron in the nucleus, and then electrons around the outside, where an element is a pure substance having only one type of atom, and they're composed of identical atoms. So if I have one copper atom, I have the element copper. If I have a box full of copper atoms, I have the element copper, either one or a bunch of them. But the minute I put something else, if I put some gold atoms in that same box, now I don't have just copper anymore. I don't have the element anymore. The element is just the thing it is. So you can think of an element like, imagine if all the Lego pieces for a structure that you're making are all sorted by color. Each color would represent a different element. So gold is an element, and oxygen is an element, and carbon is an element. But one of those, it would be an atom. And remember what atoms look like. Atoms are made of these 3 subatomic particles. You have neutrons and protons in the nucleus, and then going around the outside, you have these electrons. Now, what's really cool is that every proton in the entire universe is exactly the same as every other proton. Now, if we were in advanced physics, we would learn that there's slight differences in extreme conditions, but in nature and for the most part, every proton is exactly the same. It's not like the protons that are in gold are different than the protons that are in silver. Silver is very different than gold, though. You know what makes them different? How many protons there are. That's what makes them so different from one another. Oxygen has exactly the same protons in it that titanium does. Why do they behave differently? Why do they seem different from one another? Because they have a different number of protons. In the same way, every neutron in the universe is exactly the same as every other neutron. And every electron in the universe is exactly the same as any other electron. It's just a matter of how many there are that makes things behave the way that they do. All right, we have just enough time here to do a Kahoot if you guys want to do one. I don't think we'll be able to get all the way through, but let's give it a try. All right, you're going to go to www.kahoot.it and your game pin, or you can scan this QR code. If you have a QR code scanner on your phone or your tablet or laptop or whatever, this will take you right to the game. You don't have to put in a game pin if you use that. But the game pin is 258-5549. 258-5549. Yeah,
I have
it'll
what I
take,
do every time.
sorry, what, Isaac?
I have what I do every time.
You have what I do?
No, I have a name that I do every single
Oh,
time.
okay. Okay, that's fine. You can use your real name or you can use a nickname. The problem with not using your real name is that you don't get the glory if you get a high score. Nobody knows it's you. All right. All right. I'm gonna start now. 5. Ballet. You 1 more minute?
No, I was just I put some vinegar on one of the minerals
Yeah,
and it started like crackling kind of like
Yeah.
it was making a noise.
that's effervescence. Very cool. Very cool. Which one was it? Which mineral?
Let me check that right now.
I'm just curious.
Yeah. I think it was the let's see. Number 10 in the thing, which is talc.
Talc. Oh, that's interesting. Yeah, so talc's
Yeah.
very soft. You should be able to scratch that with your fingernail very easily.
Yeah.
All right, let's begin. You can always see the
Miss
pin.
Joseph,
Yes.
how do you get to the game?
www.kahoot.it.
Okay.
Minerals that form from magma form from the result of what? Evaporation, crystallization, precipitation, or condensation? Yeah, crystallization. So remember, there's 2 ways minerals can form. One way is cooling magma. The other way is evaporation of water that has minerals in it. So it is crystallization when it comes from magma. All right, Maisie, are you in yet?
No, I need 1 more second.
Okay, we're gonna have to keep going though, because we're never gonna finish this whole game. We'll play as long as we can. You can join in at any point there though. All right, Drake got there first and the bomb is second. Question 2. Which of the following subatomic particles has no charge? Proton, electron, neutron, positron. Neutron. Neutrons are neutral. They have no charge. And Meredith takes the lead. Question 3. What is the smallest particle of matter? An atom. Excellent. Everybody knows that one. All right. Question 4,
www.kahoot.
kahoot.it. I'll type it into the chat box for you.
Okay, thank you.
You're welcome. And the game pin is 2585549. 2585549. All right, the building blocks of minerals are elements. Elements. So I guess we should really accept atoms for that too. We say elements. When somebody asks you that, it's elements, but I mean, I can't really add credit for that one, but oh well. Helena moves up into 3rd place. All right, the tendency of a mineral to break along flat, even surfaces. There's 2 kinds of breaking. One's flat, one's rough and bumpy. Breaks along a flat, even surface. That is called cleavage. Cleavage. All right, Drake moves into 3rd. The subatomic particle responsible for chemical bonds. So what one makes it likely to bond with other atoms? Which particle? That is the electron. Electrons. It's what's on the very outside that makes it likely to bond with others who also have those electrons around the outside. All right, here we go. The color of a mineral in its powdered form is referred to as streak. Yeah, there was a hint there in the middle. The streak plate was right there. It's the streak. All right, question 8. True or false? Minerals are generally organic. That is false. They are inorganic. That's one of the requirements to be a mineral. Which of the following is not a characteristic of a mineral? It is not liquid. It is not liquid. Very good. I'm just going to fly through these. What do we call uneven breakage of a mineral? Cleavage is the nice smooth breaking of it. But what do we call the jagged breaking? Yeah, that's a fracture. That's a fracture. True or false? Different minerals have different streak colors. True. That is true. True or false? Minerals have a definite chemical composition. That is true. They do have a definite chemical composition. What is the hardest mineral? It is number 10 on the Mohs scale. Diamond. Yeah, diamond. When magma cools quickly, the crystals are they big or are they small? Magma cools quickly. They are small. It cools fast. They don't have time to get big enough. They're really little. The softest mineral would be what number on the Mohs hardness scale? Going to be a number 1. All right, we have time for 2 more. These are review questions. Are these lines of latitude or longitude? Latitude. Good. Most of you guys knew that one. Remember climbing up the ladder. All right. The USA is in which latitude? North, south, east, or west? Here we are right here. North latitude. All right. I'm going to have to end the game. So let's see our podium here. Time's up. You guys already know this. You can see it on the screen. Drake is in 3rd. Well done, Drake. 2nd place, we have Henry. And in 1st place, we have Meredith. All right. Well done. Well done. All right. So we got to all of the rock and mineral questions, but we didn't get to all the review. So I'll maybe add them to the Kahoot for next week in case we do one. All right. If you still have your kit, feel free to finish it up. test a few more of your rocks and see what you come up with. All right, everybody, have a great week. I'll see you next time.
Bye.
Thanks for
Bye.
coming.
Thank you, bye.